So this is exactly the same thing that we were doing before, but instead of doing this big rows table, we're going to represent all the reds with one branch.
Is this what, if we do this would your way on the exam?
Yes, it's fine, still fine, same thing. So if I want to calculate the probability of getting, what's the probability of getting one red, first of all? If I pull out one red, what's the probability? 4 out of 5, correct? And then the next red, this is with replacement. It's the same probability, correct? So to calculate the probability of that, what I can do is multiply the probability of each of these events together. Probability of getting a red in the first is 4 out of 5, multiplied by the probability of getting a red in the second, which is 4 out of 5. So the probability would be 4 over 5 times 4 over 5. What's the probability of, well, what is 4 over 5 times 4 over 5? How do we multiply fractions? Top by top, bottom by bottom. What's 4 times 4? Over. Have you seen that before? Now remember, this is with replacement, correct? If I wanted to do without replacement, would the first number change? Does the probability of pulling a red out first change? Where does the probability change? Second. This is where it gets a bit tricky. So if I'm doing it with, I'll use the same table. If I'm doing it without replacement, I have to change this back number. So if I pull out a red first, what's the probability of pulling out a red again? 3 over 4, correct? What about a green? 1 over 4, correct? If I pull out a green first, what's the probability of getting a red? 4 out of 4, and the probability of getting a green is 0 out of 4. You can't pull out a green, you've already pulled the only green marble out. So if I wanted to calculate this probability of red by red, it would be 4 over 5 times 3 over 4. What's 4 times 3? Over? Does that make sense? It's a lot easier, but what do I need to understand? What's different about this? I have to understand the probability of the second thing I'm drawing out. If I'm not confident with that, I need to use my tree diagram fully like that. As you go forward, you will use this a lot more. And this is really good because I can say, what's the probability of getting a red and a green? 4 over 5 multiplied by 1 over 4. Or I can say, what's the probability of getting a green than a red? And you can figure that out very quickly. Does that make sense? So you can use that technique if you prefer. You just need essentially a success and a non-success, and you can go through like that. Fill out the rest of that table if you're going through that way, and then get back on to question 2. That's an alternative method, but you're more than comfortable using that. I just find drawing lots of branches makes it hard sometimes when you've got big tree diagrams. Cool.